In this video, we're going to do lesson 1.7, which is real-world applications. And a lot of students tend to have more trouble with these because when we're talking about these real-life examples, it's hard to figure out, is it a sequence, is it a series, is it arithmetic, is it geometric? So you've really got to think about what's going on, because it's not going to be just written down, this is an arithmetic series. Okay, so you've got to really sit and think about it. So some things to think about is, first of all, you need to read the whole thing through first. Then you need to decide, all right, are we looking at an arithmetic sequence or a geometric? And write that down. And then you look and say, okay, what is the question asking me? If it's asking me for just one single number, that's going to be a sequence. If it's asking me for the total of everything added together, that's going to be a series. And once you know that, then you kind of have a guide for what formula to go with. So for number 1, I'm going to read it to you. Callie's New Year's resolution is to work out each day on her elliptical. The number of calories she burns each day is shown below. So you see those 349, 357, 365, 373. Write a rule, which means write the explicit formula for the sequence, and find the number of calories she will burn on the 30th day. So first off, let's decide if we have arithmetic or geometric. So arithmetic would be if we added the same. Geometric would be multiplying. Since these numbers are fairly close together, it's probably going to be arithmetic. So to figure this out, I'm going to take 357 minus 349, and we get 8. Okay, well, is 357 plus 8 365? Yes. Is 365 plus 8 373? Yes. So each day she's burning 8 more calories. So she's probably riding her elliptical just a few extra minutes. So, the first time she got tired of it, every day she's getting a little longer and burning more calories. So we're going to write a rule. Oh, wait, no, so we're not going to do that yet because we don't know what we're looking at. We don't know. So the question asks about the 30th day. It doesn't ask how many calories total she's burned. It only asks on day 30 how many calories is she burning just on that day. So that tells me that it is a sequence. I'm not adding anything together. If we were like, how many total calories did she burn in this month? That would be a series, but it doesn't ask that, so it's a sequence. So I have an arithmetic sequence. So my arithmetic sequence formula, D n minus 1 plus A1. That is the formula for an arithmetic sequence. I know my common difference is 8. Plug in n minus 1 plus A1, which is 349. Now, if you are in the regular Algebra 2, then you can just leave this formula as is. If you're in Advanced, I ask that you go ahead and simplify it out. So I'm going to do that. If I distribute my 8, and then I combine like terms, 8n plus 341. That is my explicit formula. And then I'm going to use that formula to find the 30th term. And we get 581. So at the end of the month, she's burning 581 calories that day. And then the next day, she would be burning even more. Eventually, she's going to be burning so many. So eventually, she'll probably level out and just do about the same every day. Okay. Number 2. Jackson bought a brand new car for $38,000. I wish I was Jackson. If the car depreciates in value by 10% each year, how much will it be worth in 10 years? So this is one of those, it helps to write out your first few terms. So starting, it was 38,000. After 1 year, so once 1 year is up, then it's going to be less than 38,000. And in order to figure that out, we're going to base it on this 10%. If you're losing 10%, that means that you still keep 90%. So in order to find my next term, I have to multiply that by 90%, which is 0.9. So when we're talking percentages, generally you're going to be looking at geometric. So after 1 year, 38,000 times 0.9 is 34,200. So think about this when you buy a new car. I don't know if these numbers are accurate, but your car loses a lot of value. So don't ever buy a brand new car unless you just have bukus of money. And if you have bukus of money, just share it with your favorite math teacher, which is me, right? Don't pick somebody else, pick me. All right, so we have geometric, and we want to know what it's worth in 8 years. So this is not going to be a series. You know, if I look at just these numbers right here, when I'm looking at what it's worth after 1 year, I don't add 38,000 and 34,000. My car is not worth $70,000. No, it's only worth that 34. So we're looking at just this sequence. We're looking at just one specific term. All right, so how much will it be worth in 8 years? This is going to be tricky because I'm not doing n equals 8. Because 38,000, that's my first term, but that's the start. My second term is actually the 34,000, which is year 1. So notice year 1 is actually my second term. Year 2 would actually be my third term. Year 3 would actually be my fourth term. And so year 8 would actually be my 9th term. These questions can be tricky. Now, if you, for example, on the test, if you pick 8 you're going to lose just a few points or half a point or something. You're going to get most credit, okay? Because I'm not really trying to test how well you can figure these tricks out. But just notice they are there. All right, so geometric sequence, A1 times R to the n minus 1 power. So my ninth term is 38,000 times my ratio is 0.9 to the 9 minus 1. And we get 16,357.75. Shoo! That is over half of what it started out as. Also, in 9 years, this car may or may not still be in good condition. So it really may be worth a lot less than that if you wreck it. But we don't care about that. All right. Number 3, Jamie opened a new savings account with $1,500. The balance for the first 3 months is shown below. All right, write a rule to represent the balance of her account and estimate the balance after 3 years. One thing that you ought to know is that this is in years where these are in months. So 3 years is equal to 36 months. You have to make sure you're using the same unit. All right. So savings accounts accrue interest, and that's what's happening here. Typically, any problem that deals with interest is going to be geometric because it's a percentage-based thing. It's not like you get 5 cents every month. The more you have in, the more money you're going to get. So it's percentage. So let's figure out what that percentage is, or that ratio. So I'm going to take 1545 divided by 1500, and we get 1.03. Let's take 1591.35 divided by 1545, and that is 1.03. So I am multiplying by 1.03. Now it's asking about a balance. And here's what most people are going to do. They're going to say, oh, a balance is a total. Well, yes, sort of. But in this case, if we think about, okay, month 1, that is my balance after month 1. This is my total balance after month 2. This is my total balance after month 3. If you go in and you look at your account in May, and you pull up on your phone or you go into the bank and you say, how much money do I have? And they say $10. And then you come back in June and they say you have $10. That doesn't mean there's $20 in there. That means you have however much they just told you at that one time. So in this case, when we're talking about balance, we're still not looking at a series. We're not talking about the sum. We just want to know the 36th term. And it's geometric. So A sub 36. A1 is 1500 times R to the n minus 1, so 36 minus 1. And we get 4,220.79. That's pretty good. you're not going to see that kind of interest in a normal savings account. So don't think that you can put $1,000 in now and then it turn into $4,000. That it's more like $1,000 in 3 years will be like $1,000 and $1,050. Okay, if that. But so don't know where she got the savings account, but I want it. Right. I'm going to skip and do number 5, and you probably want to put a big O star by number 5. Like, I'm talking big star, like notes, look at this question, remember how to do this question. That's your hint. All right, an auditorium has 14 seats in the first row, 16 seats in the second row, 18 seats in the third row, and so on. So we'll probably have 20 next. The last row in the auditorium has 30 seats. Ooh, this is not quite as easy as I thought. This is a different question than I thought. So even though you put a star by it, the question on your test isn't quite as difficult as this one, but we're going to do it anyway. So I'm going to rewrite this. 14, 16, 18, all the way to 30. So one way you could do this is you could just say, all right, 14, 16, 18, 20, 22, 24, 26, 28, 30. Because that's not too much to write out. But if this number was like in the hundreds, you probably wouldn't want to count by twos all the way. So I'm going to show you the more mathematically correct way to do it. First off, I know this is arithmetic because I'm adding 2 each time. So I'm going to fill in some things that I know. I know my common difference is 2. What I don't know is how many seats or how many rows there are. So that would be n. I don't know how many rows, but I do know that A1 is 14. And I know that my last row has 30. I know this one is a little more complicated, so I apologize, but we're still going to learn how to do it. So I distributed the 2. Now I'm going to combine my like terms. Then I'm going to subtract 12. And I'm going to divide by 2. And that tells me that there are 9 rows. Well, boo-hoo, because it doesn't ask me how many rows there are. It asks me how many seats there are. Okay, so that means that I'm going to have to find the sum. N equals 1. I'm adding all of the seats in the first row plus all of the seats in the second plus all of the seats in the third all the way up to the 9th row because that's all there are. There's only 9 rows. So 2 n minus 1 plus 14. I'm getting that formula from over here. I already did that. And then I'm going to type this sigma into the calculator. And we get 198. The questions that you see probably aren't going to be as involved or as complicated, at least for those of you that are in regular Algebra 2. Advanced, you may possibly see something like this. But we'll do some practice in class, and you can ask questions on these. I'm not going to work through too many more just because of time, but maybe we'll look at some of them in class. If you have any specific questions, let me know. Have a great day.